Hello, good morning, all of you. So, today's topic is mainly based on a very important portion of geometry, two dimensional geometry, conic sections. So, basically, in this lecture, you will learn what is the concept of the conic section, what is the definition, basic mathematical point of view, and how the name conic sections came into effect. And also, there are different types of conics you will learn about. And we'll talk specially in this lecture about parabola. So let us now go to the next slide. So let us first give you the definition of the conic. If a point moves in a plane in such a way that its distance from a fixed point always bears a constant ratio to its distance from a fixed straight line, then the locus of the moving point is called the conic section or simply a conic. So let me give you a diagram. This is the fixed point S. You look at that, you have a fixed point S, and you have a fixed straight line ML. You look at that, L is the fixed straight line. This one is your fixed straight line, and the point P is anywhere in the space, and it is moving in this plane, actually P, and this is moving in such a way that is distance from S, that is PS. PS is the distance from fixed point, and PM is the perpendicular length of the perpendicular from P to the fixed straight line. So PM is the length of the perpendicular, right? And it is the distance of P from S. So if this ratio bears a constant ratio, this is a constant. If you take the ratio, it will be a constant. E is a constant. E is a number actually. E lies between 2 and 3. So E is a number. It is a constant. Then the locus of P is called the conic. Then the locus of P is called the conic. That was the definition. So look at the definition once again. If a point P moves in a plane in such a way that its distance from a fixed point always bears a constant ratio to its distance from a fixed straight line, then the locus of the moving point is called the conic section or simply a conic. The fixed point is called the focus, and the fixed straight line is called the directrix. The constant ratio is called the eccentricity, and it is usually denoted by the letter E. So this is S is the focus, and this fixed line is called the directrix. Fixed point is the focus, and this is the variable point P. P can be anywhere in the plane, and this constant ratio is called the E. E is the eccentricity. E is called the eccentricity of the conic. So there are three cases. If E equal to 1, it is a parabola. If E less than 1, it is an ellipse. If E greater than 1, it is a hyperbola. Parabola, ellipse, and hyperbola. Okay. So that was the basic definition of the conic. From mathematical geometrical point of view. Now this is again, it is written in this form that if AE less than 1, the curve traced out by P is called an ellipse. E equal to 1, then the curve traced out by P is called the parabola. E greater than 1, the curve traced out by P is called the hyperbola. So there is a theorem. Every conic section is represented by means of a second degree equation. What do you mean by second degree equation? The second degree equation is like this: ax squared twice hxy plus by squared plus 2gx plus 2fy plus c equal to 0, right? This is the conic. This is the second degree equation. So every conic section represented by means of a second degree equation. That we'll see later. Now, why this conic section name? Why this name conic section? There is a important fact about that. So conic section derive their names from the fact that they can be obtained by plane sections of a double right circular cone. So you can see that this is a right circular cone. It is a right circle. This is the base of the cone. This is called the vertex of the cone. So if you take a section of the right circular cone, different portions in different positions, if you take a plane section, then it will give you different types of curve. Look at that. If you take a section perpendicular to the axis of the cone, it depends on the angle. If you take the this is actually perpendicular to the axis of the cone. This is the axis of the cone. So if you take the section perpendicular to that is theta equal to 90 degree in this case. So theta equal to 90 degree, that is the section with the axis and the plane, and that will give you a circle. If you take a different angle, suppose theta is some different measure, then it will give you an ellipse. So this is the section. And if you take another section, acute angle section with the axis of the cone, it will give you this is the angle of intersection. So this will give you parabola, and there are hyperbolas also concept of. So conic sections actually derived from their names from the fact that by plane sections of a double right circular cone. So if you take a sections of the right circular cone by a plane, different positions making angle with the axis of the cone, you will get different types of curves: circle, ellipse, parabola, and hyperbola. Okay, so that is the why the conic section name is there. This is another geometrical concept. So you can see this, visualize this diagram separately. Look at that. This is the axis of the cone. If you take a this is the perpendicular to the axis of the cone, you will get a circle, and this is actually the second one is the ellipse, and the third one is the parabola. And you see there are two sections, one at the top, one at the bottom. So these two sections together is called the hyperbola. Okay, so this is how you can get the sections, and different curves will be generated. Now let us come to the first one, parabola. For parabola E equal to 1. For parabola E equal to 1 means the distance, if you take a, okay, let me take a page and let me illustrate your concept here. So there is a fixed point S, and there is a fixed straight line L, or this is a fixed straight line, and a moving point P. P is anywhere, it's moving in the plane. So you can get SP, the distance of the focus from the, this is focus of the conic, and this is actually directrix. And from P you can draw perpendicular, from P you can draw the perpendiculars. So this is your PM, and you can take SP by PM, the length of the perpendicular. This ratio is a constant, equal to 1, E equal to 1 for parabola. Okay, so this SP equal to PM, right? SP equal to PM. So that will give you the equation of the parabola. Suppose your S is the focus and P is any point x comma y, and this, if you know this straight line, you can get the equation of the parabola from this equation, from this relation. So SP equal to PM. So if you square, you will get, suppose the focus is a comma 0. Suppose the focus is, for your simplicity, if you take the focus as a comma 0, and SP you can calculate x minus a whole square plus y minus 0 whole square, that is equal to, it will give you, and the distance, this distance can be calculated, and you will get the first equation of the parabola, standard form, y square equal to 4ax. Okay, so let me draw the axis. It will be better for you to draw the axis of the parabola. This is x-axis, this is y-axis, and this is the parabola. First standard form. What is the standard form? Y square equal to 4ax. This is the simplest form and the standard simplest form. Okay, y square is equal to 4x. And look at that, this is called the vertex. Vertex is at 0 0, and this is the fixed point focus. Focus is A0, and this is the directrix. Distance of the directrix from the vertex is equal to the distance from its focus. So if this distance is A, this distance is also A. So this is the directrix. Okay, so what is the equation of the directrix? Equation of the directrix is x equal to minus A, right? Because this coordinate is minus a comma 0. This is negative side of the negative direction of the x-axis. So minus a. So x plus a equal to 0 is the equation of the directrix. So look at that, and P is anywhere. P is any point on the parabola x comma y. Okay. So what are the points here? Number one, axis. What is the axis of the parabola? Axis is positive direction of the x-axis. Look at that. This is called the axis of the parabola. This is called the axis. So positive direction of the x-axis, right? Positive direction of the x-axis, right? Positive direction of the x-axis. Number two is focus. What is your focus? Focus is a comma 0, right? Focus is a comma 0. Look at that. Your focus of the parabola, this is the fixed point, is a comma 0. Number three, what is the vertex of the parabola? Vertex is 0 comma 0, right? Vertex is 0 comma 0. And number four, equation of the directrices, right? If you write the equation of the directrix, you have only one directrix. In case of ellipse, you will find there are two directrices. So equation of directrix is x plus a equal to 0. Why this is x plus a equal to 0? Look at that. The distance of the directrix from the vertex is equal to the distance of focus from the vertex. So these two distances are equal. So this is x equal to minus a because it's parallel to y axis, right? So x plus a equal to 0 is the equation of the directrix. Another thing is that a perpendicular on the vertex, on the focus, passes through the focus. This is called the latus rectum. This is called the latus rectum. L dashed is the latus rectum of the parabola. Length of the latus rectum is 4a. So another important thing is length of latus rectum, right? Length of latus rectum is 4a units, right? Length of latus rectum is 4a units. This distance, that length of this L dashed is 4a units, and this is symmetric about the x-axis. So this length is 2a and this length is 2a. So what are the extremities of the latus rectum? The coordinate of L is a comma 2a, right? And L dashed is a comma minus 2a. Okay. So these are the extremities of the latus rectum. Okay, clear? So these are the important things for a parabola. The first type of parabola, y square is equal to 4ax. If you look at the second type can be written as y square is equal to minus 4x. Let me show you the second one. Yeah, the second type is y square equal to minus 4ax. So that means the negative direction, its direction will be negative direction of the x-axis. So look at that. This is the parabola. The vertex will be 0 0, but you have a focus in the negative direction. This is negative direction. X-axis is just reverse in the negative direction. So focus will be minus a comma 0, right? Vertex is same, and directrix will be opposite direction of the focus. So this is your focus. So this is a 0 point, right? So x equal to a is the equation of the directrix. Length of the latus rectum remains same, 4a, and the coordinate of the L, the extremities, it can be minus a comma 2a and minus a comma minus 2a, right? Okay, this is the second type. This is the second standard form, y square is equal to minus 4x of the parabola. And how you are getting this equation, that may be the question from your side. The answer is you are getting this from the relation SP is equal to PM. The distance will be same from the definition of the conic. So another form, next form will x squared equal to 4ay. This is another form of the parabola. And how will you get this? This is actually, yeah, this is the curve. This is the parabola. It's not very good diagram. Let me draw. Yeah, this is the parabola. Its positive direction of the y-axis is the axis, and vertex is 0 0 always. In this case, your vertex is 0 0. Origin is the vertex, but focus is on the y-axis. So it's 0 comma a, right? 0 comma a. This distance is always a. and because of this A is here, you look at that, and this 4A is the length of the lattice rectum. So your length of the lattice rectum is 4A, and your directrix is parallel to x-axis, so y equal to minus A, right? So this is the feature. You can draw, you can write all others, no problem with that. And the last one is x square equal to minus 4ay. So you know that how to get that. This is actually negative y-axis. Negative direction of the y-axis is the axis, and in this case your focus will be 0 comma minus a. Yeah, vertex is 0 0, right? And your directrix is, this one is the directrix, it's y equal to a, equation of the directrix. So this is how you can deal with this type of equations. Okay, so let me show you. Yeah, this is the diagram. I already explained this diagram, and there are four types. The first one is y square is equal to 4x. I explained, and y square is equal to minus 4x. So this will help you to help you to actually graphing the parabola. Graphical knowledge is very, very important, and I will explain this part also. If the vertex is not at 0 0, so this is, look at that. If the vertex is not at 0 0, it will shift the origin. The vertex is shifted to some other coordinate h comma k. Then what will happen? What will be the equation? That is also a standard form. I will discuss. So this is your x square is equal to 4ay, x square is equal to minus 4ay. Okay. This is again, if the vertex is not at origin, it is shifted to some place, some point h comma k. And this is a chart for your better understanding. All other coordinates of the vertex, in all the cases you have 0 0 0. Coordinate of the focus, equation of the directrix, equation of the axis. You know this is positive direction of the x-axis, positive direction of the x-axis, negative direction of the x-axis, but equation, and length of the lattice rectum, 4a, 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 focal distance of a point. Okay, this is also is there, and this is the I will describe this thing also. So I will describe now. I will describe now. Yeah. So I will describe when the vertex is not at origin, right? When the vertex is not at the origin. So what will happen? So let me take the axis first. Okay. This is the axis. So this is the origin. This is x-axis, y-axis. This is x-axis, right? Now, if the vertex is not at origin, but it is shifted to h comma k, right? Then this is the axis of the parabola, and this is the diagram of the parabola. Okay? Now, what is the focus? Now the question is, what is the focus of the parabola? And this is the directrix. What is the focus of the parabola? Focus will be a plus h comma k, right? Because this distance is h, and this portion is actually a. So h plus a is the combined length of x coordinate and abscissa, and ordinate is height is always k. So a plus h comma k is the focus of the parabola. Then what is the equation of the directrix? This point will be h minus a comma k. So directrix will be, equation of the directrix will be x equal to h minus a, right? This is the equation of the directrix, and length of the lattice rectum will be 4a in this case also. Length of the lattice rectum will be 4a in this case also, and the coordinate, what will be the extremities of the lattice rectum? Extremities will be a plus h comma k plus 2a, right? Because it's symmetric, 2a, 2a, and the lower one, that is L prime coordinate of L prime will be a plus h and k minus 2a, right? This is the extremities. Okay, and axis is parallel to the x-axis. Axis is parallel to the x-axis. Then what is the equation of the parabola in this case? Y minus ka whole squared equal to 4a x minus h. Okay, 4a x minus h. So that is the standard form of the parabola if the vertex is not at the origin. If the vertex is not at the origin. So if hk is 0, 0, you will get the y square is equal to 4ax form. So if the vertex is not at the origin, you can sketch this diagram. You can evaluate the values of the necessary things: focus, directrix, extremities of the parabola, length of the latus rectum, vertex, everything from the diagram. A picture worth 1,000 words. So if you remember the picture, you can get everything from the diagram of the parabola. Another thing I will explain: if the form of the parabola is x minus h whole square, this one is actually y minus k, x minus h whole square, 4a into y minus k. This is another standard form if the vertex is not at the origin, but it is at hk. Vertex is at hk. So you draw the diagram simply. You try to draw the diagram. Take a coordinate axis parallel to the axis. This is x-axis, right? This is y-axis. This is the origin, but origin is not the vertex. Vertex is hk. So this is your hk, right? You get the point hk from here. So you draw, yeah, this is the parabola. So its axis is parallel to the y-axis, parallel to the positive direction of the y-axis. So you can get the vertex. hk, focus. What is your focus? Focus is h plus a. No, not h plus a. The vertex will be in this case h comma k plus a, because it's a. This length is a, right? So k plus a. This point is hk. So your length in the vertical direction increased. So h comma k plus a. And this side you will have directrix, and the coordinate of the directrix is h comma k minus a, right? So what is the equation? Equation will be y equal to k minus a. Y equal to, because it's parallel to the x-axis, so y equal to k minus a is the directrix. And you will get the length of the latus rectum 4a in this case also, and you will get the extremities of the latus rectum, so on. So let's come to the table. There is a table for you. Yeah, let me show you the table. Yeah, you see x minus h whole square equal to 4a y minus k, y equal to k minus a is the directrix. Focus is written here. Vertex concave up, down, it's upward direction, downward. So all the things are given in the chart. Okay, everybody? So it's for your better understanding. Okay, so that is about the parabola. And what is the parametric equation? Next important point is the parametric equation of the parabola is given by x equal to 80 square comma y equal to 280, twice 80. T is a parameter, t being a variable parameter, because it satisfies this equation. If you substitute x equal to 80 square in the equation of the parabola and y equal to 280, it will satisfy the equation of the parabola. So any point on the parabola, any point on the parabola can be represented by the parametric form 80 squared comma 280, right? 80 squared comma 280, that is a parametric form where t is a parameter of the parabola. So what is the advantage of taking this parametric form? Because if you take x1 y1, you are taking two values, two unknowns, x1 y1. But if you take the parameter only one unknown, that is t is the only unknown. So there will be more advantage on taking parametric form. If your form is x square equal to 4by, you can take the parametric form also in this form. Okay, let's now tell you about the focal chord of the parabola. What is the focal chord of the parabola? Any point on the parabola can be taken as 80 square comma 280, that you have learned. So you take another point q as 81 square 281. So this is called the actually pq is the focal chord of the parabola. Any type of chord, you can take this type of chord. There are infinite number of chords of the parabola parallel to this, or you can take this is the parabola. This is not the focal chord, but this is PQ is the focal chord. PQ. So there are a lot of chords. They are chords, but focal chord means it passes through the focus. Focal chord means it passes through the focus of the parabola. Those are called focal chord. So you can pass infinite number of lines through the focus. Okay, so this is the focal chord of the parabola, and very important results for focal chord. This is very important, very important. T1 T2 equal to -1 for a focal chord. If PQ is a focal chord, then it will satisfy T1 T2 equal to -1. I will give you a hint for that. Suppose how will you get that? Suppose you can get the slope of PS, slope of, you can get the slope of PS, that is M1, y2 minus y1 by x2 minus x1. So 2at minus 0, right, by at square minus a. This is M1, and you can get M2. M2 is the slope of QS. Slope of QS. So 2at1 minus 0, right, by at1 square minus a, right. So if you multiply this, it will be okay, you will get this. Now this is the same line it is represent. So slope of PS is equal to slope of QS. So if you equate, you will get T1 T2 equal to -1. This is a very important result in parabola, that for a focal chord T1 T2 equal to -1. So similarly, you can get the, if P is a point this, you can get the length of the focal chord. You can try this result. This is the length of the focal chord. And for a semi-lattice rectum, harmonic mean, semi-lattice rectum is the harmonic mean of SP and SQ. Semi-lattice rectum is lattice rectum is 4A, so semi-lattice rectum is 2A, and that is the harmonic mean of SP and SQ, where P and Q are extremities of the focal chord. This is also the, so these three results are very important. You can go through the results. Okay, so this is about your focal chord. Let's come to the last section of our chapter, some real life applications of the parabola. You can see the diagram. It is in US, the cantilever bridge. It is on the river. So this is actually, this is the parabolic shape. So this is a real life engineering problem. So a lot of in Kolkata also you have second Hooghly Bridge. So these are all application of this parabolic concept, because some engineering applications and some facilities over there, some advantage of taking parabolic shape. And this is the reflector parabolic shape of satellite dish, helps receive and transmit signals. You know that if your signals is coming to the parabolic reflector, it can be used as a parabolic reflector. So you see that parallel rays of sunlight is coming and they will meet at the focus. So this is a parabolic reflector. So there are real life applications, a lot of real life applications of the parabola. Okay. So in this lecture, I mainly talk about the conic section, concept of conic section, parabola, and different types of conic section, parabola, and the application of parabola, different types of standard form of the parabola. If the vertex is not at the origin, that also discuss in this video. So follow my lecture video. I will share with you the next video in my YouTube channel, that will be on ellipse and hyperbola. Okay, thank you all of you.